I'm here for your Firebase break. Why are you doing this to me? Stop being full screen. Try that again. Nope, that was not what I wanted. Okay, good. Sorry about that. Okay, so I'm Natalie Simmons. I work at TribalScale. It's a bit about TribalScale, downtown company, Ranger Swag, we're hiring. So a bit about me. I started coding in high school, but then kind of went off the beaten track and went into biomedical engineering. Found out it wasn't really for me and ended up at Ryerson doing computer science. I started coding in Android like the last summer of university, so like roughly 2 years ago. It was at an internship over the summer. It was kind of a low-key internship, but I really enjoyed it and kind of decided from then on I wanted to do Android professionally. And then I started doing that. Started at TribalScale at the beginning of this year. Since the beginning, I was working on the ABC News app, their Android version, obviously. And around July, August, I became the lead engineer on the project. So we're here to talk about legacy code. Legacy code the term itself has like a bit of a legacy to it, so to speak. It's basically when people have to deal with code that is either obsolete or like technology that people don't really use anymore and is not widely available. So people kind of become these niche things that they have to work on, and it's still there today. But the term has evolved, obviously, as most things in the English language do. And so for the more Android, more modern sense of the word, when we talk about legacy code, we mean code that's been inherited, usually from like one company to another, or from one developer to another. It kind of has its own set of features and like issues that it comes with, which pop up all over the place. Even between developers within the same company, you can kind of have legacy code issues popping up. A developer might leave the project and not remember how or what they did, and then the next developer is kind of confused about what's going on. And so you kind of end up with these problems. Obviously, all development has its issues. There are challenges in all parts of development, in most facets of computer science as well, but kind of legacy code has its own set of extreme issues that makes it like really annoying to work with. So just dive into them a bit. Legacy code can be very confusing. Most of the time, people who worked on it don't even remember what they did anymore. And it kind of becomes this issue where people have to work with it, but they don't want to know how to work with it, so they keep making more problems on top of it. And it kind of just compiles with each person that gets the code base afterwards, because they're not really sure like what the code that they're supposed to be developing with and the system they're working within, how it's supposed to function. So people are easily making mistakes, and often there's no documentation, there's no real context, so people just kind of go with it and don't really think about what they're doing. And then their second issue is just it's outdated. You get problems with like deprecated classes in Android specifically that when you try to upgrade, you get more issues. Also just like modern technologies that you might want to use might not play well with the old code. So it just kind of becomes this catch-22 situation where you have to upgrade to further your development and be up to date, but if you upgrade, things might break in your code base, which happens a lot actually. And the last one is just that code gets messy. If a bunch of people who don't know what they're doing keep piling on top of code that they don't understand what they're doing, it just gets worse and worse. And you get stuff like copy-pasted code and code that does the exact same thing as another part of the code base. And it just becomes this kind of monster that no one wants to deal with, and it just escalates more and more as it goes down. So there's no silver bullet for it, unfortunately, but there's two things to like always keep in mind at all times when working with legacy code is, and people don't like it, you have to study the situation. Most of the issues from legacy code, other than the fact that they're obsolete and people might not really know how to use those old technologies anymore, it's just that people don't want to understand them. So if you just take some time, study it out, and then use your head and adapt to that situation, it's a lot easier and a lot better for the people coming after you as well. So at TribalScale, I have been working on the ABC News app, as I mentioned. And this is kind of where this talk comes from. A lot of the issues we had with ABC is because it is a prime example of legacy code. The app was first published in 2011, so it's pretty old, more than 4 years old now, and we are the third company to inherit the code base. So a lot of us, when we first got it, didn't fully understand it. There was a lot of like reverse engineering kind of working with it, and we kind of figured out there's some strategies that we had to work with and kind of discovered as we went. Um, Basically, we had like 3 flows that we kind of work with. We had different challenges, obviously. One of them, for instance, we had to switch out push notification providers. There was absolutely no documentation on first push notification provider, so we kind of had to figure out how it worked entirely before we could do anything new. And then there was a more extreme case where we had to, basically we did the redesign for the app a few months ago, which we had like a crazy deadline of like 3 or 4 months to complete a full redesign in. So we kind of had a lot of challenges which we had to kind of juggle along with the legacy code aspect of the code base. So what I have here is just kind of like a spectrum. Generally, you don't take one and run with it, because obviously you're gonna have to adapt, but you can kind of choose which one works for the situation, kind of blend them a little bit, and you might have a lot easier time working with legacy code. So the first one is working with what you have, obviously. The code base is there. It might look scary, but generally, unless someone gave you a broken app, it functions. It has all the features you need to. You might need to maintain it or add features to it, but generally it works. So tips that we like to use, obviously this method is very solely based on understanding what it did and what the legacy code is actually trying to achieve. So just study it, like really do it. Like we love our whiteboards at Tribal Skill. Just like nothing's better than just figuring out how the whole thing works. It's kind of almost therapeutic after a while. You just have to discover it, log it, like breakpoint it, do whatever you have to do, just try and understand how it works exactly. Also, keep your eyes on what you're supposed to be doing. Legacy code can be very distracting because a lot of things you don't understand it, and you might be thinking, okay, well, code is supposed to look like this, why doesn't it look like this? So you might try to like spend some time cleaning it up or making it look how you want to, but you're actually there for a goal. You have like either a feature you have to do or a bug you have to fix. Don't get distracted by something that you don't enjoy looking at, so to speak. Also, that being said, campground rules. Generally what that means is you leave it better than you found it. Clean it up as you go kind of thing, make sure that you're not adding to the problem, but also don't clean the whole forest. Just like clean your campsite. Like make sure that what you're working on gets cleaned, but don't dive down the rabbit hole and start cleaning up everything, because you'll end up giving yourself a lot more work and like increasing development time, and you might just end up making more problems that you were trying to solve in the beginning. And lastly, just make sure what you're writing adds value and isn't already there. A lot of the time I've seen like parts of code base that do the exact same thing that another part does, or like systems don't really work well together because there's parts that are functionally not making sense because like someone's trying to make something somebody already did. So generally read up on what you're doing, just make sure that it's actually adding value. So what we actually do, like that was the nice thing, but what I actually do is when I'm working with my legacy code and I have to work with what's there, I whiteboard a lot. I whiteboard everything. I have to go through every method. I make sure I at least have a very high top level understanding of what the code is supposed to be doing. And then I develop with the legacy code until I'm completely sure that I have my feature done or my bug fixed. And then you can just, if it's completely obsolete, just kill it off. It's like kind of therapeutic to know that you have your thing to look off of. So you have your code that's there before. Make sure that everything that you're making that's new or that you're kind of trying to fit into the system works the way that it's supposed to, and then you can remove your legacy code. Because if you just remove it, you won't know what it was doing before. You might end up with a bug being like, what is going on, but really the thing you just deleted might have been solving that bug. Or any gotchas that the developers from before had fixed. If you get rid of them, you'll never know what the person was trying to achieve, because as much as you try to hate on legacy code, it's there for a reason. It might be outdated, but people were just solving the problems of the time or working with the solutions that they had at hand. So if you are in a situation where you can start from scratch, either making a new feature or you have a sweet redesign time that not a lot of us get, I'm not really going to tell you how to do that because you all know how to code. You're going to code how you want, but there are things to remember when you're starting from scratch inside of a legacy system. Your code doesn't exist in a vacuum, so you're going to have to keep studying the code still, unfortunately. There are reasons why the previous owners did what they did. So if you try to make something completely new and do not respect the system you're working in, you're going to make more bugs. So always know that whatever you're making or whatever you're trying to rewrite, it still has to fit inside of the overall system that you're working within. Also know this is the riskier option. Because you're working in the unknown, a lot of developers have done what they did to kind of alleviate problems, or they knew the business logic requirements. If you're starting from scratch, you kind of take that on yourself. You have to discover everything, and if something goes wrong, it is unfortunately on you. Also, make sure that if you are starting from scratch, that you're not doing it out of almost, this is my way and I'm gonna do it my way. Know that what you're doing has to add value to the situation and not just remove things or rewrite something because you didn't like it. If you think you can do better, you have to know you can do better, because if you just rewrite something from scratch and it's more broken than before, you're creating more problems than you're actually fixing. And then the last one is kind of take what you need situation. I like to call it Frankenstein's codebase, because you're basically taking something, starting from scratch, but you have all that legacy code there, and it would be a shame not to use it. So basically, take a little bit of like taking what you need and just starting from scratch. You just kind of find a midpoint. Generally what we do, this was something we used heavily during redesign, and also because we were short on time, this does tend to put development time down a little bit. You start off on a blank page, know your function obviously, and if you read the code base enough, study up on it, make sure you know what it does, and all the functions do exactly what you think you can do, then you can just kind of cherry pick what you need. So if you take like one function and another function and then build on top of it, eventually you will have a fully functioning system or a fully functioning feature without having to write everything from scratch and then deleting stuff that's already there. You also get the benefit of all of the bug fixes that any of the previous owners may have done, or any of the like surprise things that the feature might have had. They're already in there. Also, it makes it's kind of nicer to look at. You don't have to start off inside of a big system. You just have a clean slate. You can one at a time pick things, build around what you need, fix what you need, and it's not all inside of this massive code that you don't really understand and don't want to look at. So yeah, just going to develop that further. It's a lot clearer. If something breaks, you know why, because you just took that one method. So if you take that one method and your code breaks, you'll know that's what broke it. If you're running your project and you notice it's not working the same way that it did before, you'll know you're either missing something or you broke something. Also, again, if it's done right, it saves time. You don't have to go around rewriting everything, and you don't have to spend all that time trying to see, okay, did I do this, did I do this, did I do this? Because you know from what you're looking at, if something's not working, you know you forgot something. Also, it's kind of gives you the same feeling as starting from scratch, because you do have room to innovate and you do have room to improve on what you've been doing, because you do have a fresh slate. You can just kind of work around what's already there. Okay, so I don't know how quickly I ran through that. But in conclusion, just the main thing is always, oh my, I'm gonna have a lot of questions. Main thing is always study the code. Just make sure you know what you're working with. And then after you've done that, adapt to the situation. Know that just because something worked before doesn't mean it'll work now. The situations change, you might have a different timeline, you might have different features you're trying to work into. So always adapt to that situation. And lastly, do as I say, not as I do, don't panic. It's frustrating 90% of the time, it's also confusing, but there are usually reasons why people did things, and the more you look into it, the more you explore it, you'll understand that there's a reason why people did what they did, and you can work with it. Slowly but surely, like, you can clean up legacy code systems to make them less jarring. And of course, the spectrum. Just don't know that it's not going to be one or the other. You can usually work between them because they do tend to blend into each other. Just make sure that you are using what you should, not what you think is nice. So, any questions?